In this video, we'll talk about application of the derivative to economics problems. So another way you can use derivatives in applications and think about them as rates of change is in economics. If you have a business and you have a function c of x that describes how much it costs your business to produce x items, what is c prime of x? Well, c prime of x should be the sort of rate of change of this cost with respect to how many items you produce. So it's something similar to the idea of if I were to produce one more item, how much more is that going to cost me? In economics contexts, this is usually referred to as the marginal cost, which is sort of the cost to produce one more item than you already are. And the point of using the derivatives application here is that we can use c prime of x to approximate this marginal cost. And you can do the same thing for revenues and profits, things like that as well. And it works the same way. You can also think of this as a sort of sensitivity to change idea. The idea being, if c prime of x is really big, then making one more item costs a lot of money. So where you're at in your process is really sensitive to how many things you make. On the other point of view, if c prime of x is positive but really small, it means it doesn't really matter too much how much you make. It's not going to affect your overall cost that much. So in this last case, my process is really not that sensitive to change. It doesn't really matter if the numbers go up by a little bit or down a little bit. My costs really aren't going to change that much. This would be a low sensitivity situation, which is indicated by a small derivative. Let's now look at an example with an economics problem. Assume your company can produce x widgets for a cost given by this function, x cubed minus 4x squared plus 10x plus 2, and the revenue you make from selling these is x cubed minus 2x squared plus 8x. Assume you currently make 20 per month. About how much actually would it cost to increase to 21? And is it profitable to make that change? So, about how much would it cost to increase to 21? This should be the marginal cost at 20, which is about c prime at 20, which I can find by taking the derivative and then plugging in 20. So c prime of x is going to be 3x squared minus 8x plus 10. And I can plug in 20, gives me a marginal cost of $1,050. Now, is it profitable to make this change? Well, to do that, I'm going to need to figure out what the marginal revenue is for going from 20 to 21 and see if that outweighs the costs. So what's the marginal revenue at 20? Well, this will be r prime of 20. So I can find r prime of x, which is 3x squared minus 4x plus 8. And I can plug in 20 here. So r prime at 20 is going to be $1,128. $1,200 minus 80 plus 8. So is this change profitable? Well, the answer here is yes, because the revenue that I would gain by making this switch is more than the extra cost I would spend making this switch. So since r prime of 20 is bigger than c prime at 20, the increase to 21 widgets per month is profitable. That's the idea of how derivatives can be used to solve applied problems in economics. It was an example of one of those problems. You can see why the derivative can be so useful in figuring out what's going on here. You could do this problem by just plugging in 21 and 20 and subtracting them and see what happens there, but using the derivative gives you a simpler way to figure out whether or not there's going to be a profitable change or not without having to go through all those steps.